Hi there and welcome to another part of the Solidity tutorials. In this part we're going to extend the ERC20 smart contract and use Openzeppelin library in order to create one. So the contract that we wrote previously called ERC20 is going to be much bigger and it will have much more features and functions so that we can create a much more standard kind of ERC20 token. And also notice that right after that we will also be able to add some other features to the smart contract so that we will have more customized token. So notice that the smart contract that we're going to work on might be a bit long, and also notice that you don't have to use that every time you want to create a smart contract, meaning that you just need to import the library and then customize the token just in a way that you want in just multiple lines that you want to add. So each time you don't need to write the whole contract, you can create a factory and then make that happen. So first of all, before I want to get started with the contract, I'm going to introduce the Openzeppelin library and Openzeppelin contract GitHub repository. Here you can see the IERC20.sol, which we're going to import inside of your project, and also ERC20.sol. So let's take a look at each one of them. So ERC20.sol, it will use the IERC20 metadata and also IERC20.sol. So we mainly want to use this one instead of this one, and this contains some of the functions and also some of the codes that you may need to use in order to write your own contract. So you may want to use them. They're just similar to what we wrote previously on the ERC20 contract. So there are just some functions. Notice that it will have the burn function and also mint function, and so some other functions that may be similar to what we had in the ERC20 contract. Also, this is the RERC20.so. So even if you want to write your own contract on VS Code, you will need to download this and put it inside of your directory. But if you're writing your contract inside of the Remix IDE, then you will only need to import the address or link to this GitHub repository, which we will do in just a few minutes. So if you're ready, we can get it started, and you can take a look at these libraries inside of the GitHub repository of Openzeppelin. But we will get started and we'll learn each one of them. So notice that here there are a bunch of events and functions which you can override, and I'm going to tell you what override is. And so don't worry if you don't understand some of these names and functions and some of the expressions like override, but I'm going to explain this. And because the contract is a bit long, I'm going to have to divide the tutorial into different videos. So make sure you follow along with all of the videos so that you can understand the whole contract. And in the future, if you want to use the Openzeppelin, we will just import it and change some of them, and also use the factory in order not to have to write the whole contract by ourselves. So just as always, let's get started and create a new file. Here I'm going to write Openzeppelin. So it needs E here, and I can say ERC20.sol. And notice that this is not necessarily the same as what we have inside of the GitHub repository. It might be just a bit different, but it's generally the same. It has 90% similarity to the ERC20.sol, but it might be somehow different because we have decided to change it a little bit. So just as always, we can copy and paste the first two lines here and paste it inside of our contract. So now let me zoom a little bit so that you can better see the whole contracts. So now we're going to import the two libraries related to the Openzeppelin. So I'm going to write it down. You don't need to do that. You can just copy and paste. But because I want to make sure I write everything right, and you can follow along with me and write it, but you don't have to. So Openzeppelin, and then we'll have contracts, token ERC20, token ERC20, and IERC20.solve, IERC20.solve. And from now on, we will copy and paste the library. So import Openzeppelin contracts utils. So up to here, we can copy and paste. And then utils math and SafeMath. And I will explain why we use this library. So SafeMath, let's make sure we write it okay. So Openzeppelin contracts utils math SafeMath, that's all. Okay, so you might have had this experience where we face the overflow. So for example, we define a kind of variable uint8. So I had this example uint8, and then we enter some kind of number for that. So for example, variable, right? And then we enter a number as a user, something more than 255, right? It becomes 256, and then the overflow happens for this number. Why? Because it won't be 256 anymore, it will be 1. So this is overflow, and in order to avoid that, we will use the library called SafeMath.solve from Openzeppelin so that we can avoid this thing to happen. So let's write the contract here. Contract MyToken is IERC20. MyToken is IERC20, and you might wonder why we write such kind of sentence like this. So most of the time we have, actually all the time we have written this contract MyToken and then open the brackets, and that's it. But here we're using is IERC20, and the reason we do that is that we're going to use the IERC20.solve library, and we're going to inherit the functions from there. So notice that when we go forward and write our functions, some of our functions will also have the expression overwrite, and that means that we're using the IERC20.solve functions, but we want to change them in a way that we like and customize them, so in a way that it is not like the main function or inherited function. So overwrite here means that we're going to overwrite the function in some way, or use it, inherit it, but make our necessary changes. But if we don't write the overwrite, then the problem that will happen is the compiler of our Solidity smart contract will then mix, for example, approve from IERC20 with the kind of approve that I have written. So in that way, we need to write returns overwrite and then the rest of the function. So now we'll get there, but for now let us also write here using SafeMath for uint256. So most of the variables that we'll define is uint256, but because there's this danger of overflow even for this very big number with uint256, then we will use this using SafeMath in order to avoid that from happening. And then we'll have two mappings here. Mapping one is address to uint56, address to uint256, and then we'll have the private balances, and another mapping is address to, so this is just the same as what we had for ERC20, the previous contract that we have written, and there's a mapping inside of the mapping. So we have a mapping here, address to uint256. So this is a mapping instead of a mapping, and this is for the allowance. So private allowance, that's it. So there are two mappings. The mapping one is for the mapping of the address, the owner, to the balances of the owner, and another mapping is a mapping instead of a mapping, which is the address of the owner to the address of the spender and the amount that is allowed for spending. So right now we're going to define some other variables. uint256 private, uint256 private, total supply, and uint256 private, the name, also the same for the symbol, uint256 private symbol, and uint, actually, oh, here we need a string, so we never use uint256 for the name and for the symbol. And then we'll have uint8 private for the decimals. And the reason we do that is that the number related to decimals is not most of the time bigger than 18, and we use uint8 without ever worrying about the SafeMath function. You can write SafeMath function for uint8, but because the decimals is not a big number, then we'll never be worried about that. So now we can write the constructor and open the parentheses here. Now we'll have a string memory name, a string memory name, the underline afterward. I will explain that. A string memory symbol, a string memory symbol, again underline afterward, and uint8 decimals, uint8 decimals. So there we go. And afterward, here instead of it, we'll get name, underline name, name with name, underline afterward. And also the same for the symbol, symbol equals to symbol, the underline afterward. And also the decimals stand the same. Decimals and decimals. There we go. So up to now we've written the oh, and by the way, here we should open the bracket. So up to here, we've defined the constructor, the variables that we've been looking for. Now we're ready to write our functions. So we'll continue this in the future tutorials and in the future videos. So there are some series of videos. There are a number of functions that we need to write and explain, and then we will deploy the contract here on Remix IDE. So until the next video, goodbye.